You spend most of your time indoors, right?
Yeah.
But are you really aware of the invisible threats maybe lurking in your home's air?
That question, yeah, it's from one of the sources you sent, and it really does make you stop and think.
It does. Welcome, everyone, to our deep dive into the articles, research, and info you've shared with us.
It's such a critical topic. We worry a lot about, outdoor pollution, but the air inside our homes, sometimes it's actually worse, more concentrated with pollutants.
Exactly.
Yeah.
And it can impact our health in ways we might not even connect.
Absolutely.
So our mission today is basically to unpack this stack of sources.
Yes.
We're going to dig into what's actually floating around in there,
Yeah.
understand how air filtration systems, as described here, work against it, and then look at some pretty compelling science and a specific solution that popped up in your materials.
Right. Think of it like we're turning on the lights in a dark room, the room being your home's atmosphere, and seeing what these sources say you can actually do about it.
Okay, let's get into it. Those invisible threats. What exactly do the sources say is lurking indoors?
Well, they paint a pretty clear picture. You've got the usual suspects, common allergens like dust, pollen, pet dander.
Right, the stuff that makes you sneeze.
Exactly. But then there's more. Things like smoke particles, bacteria, viruses, even mold spores.
Ugh, moles.
Yeah. And also various kinds of particulate matter. The sources specifically call out PM2.5 and PM10.
PM2.5 and PM10. Okay, that sounds a bit technical. Can you break that down? Why are those important according to the sources?
Sure. PM just stands for particulate matter. The numbers refer to the size. PM10 means particles smaller than 10 micrometers. Think dust, pollen.
Okay.
PM2.5 is even smaller, less than 2.5 micrometers. Really fine stuff. And the sources stress these because they're so small you breathe them right in. They can go deep into your lungs.
And cause health issues, I assume? What kind of impacts did the sources talk about?
They do. Poor indoor air quality, according to these documents, can really affect your health, especially if you have allergies or asthma. It can trigger symptoms, coughing, wheezing, shortness of breath, but they also link it to things like headaches, feeling tired, and just general respiratory problems.
One source you sent mentioned something called the Atopic March. That was a new one for me. What's that about?
Ah, yes, the Atopic March. It's a concept described in one source. It basically refers to this common pattern or progression of allergic diseases.
Progression, like how?
Well, it often starts early, maybe with eczema in infancy, then influenced by things like genetics, but also environmental factors like air quality. It can develop into food allergies, then maybe allergic rhinitis, which is basically hay fever, and eventually asthma.
Wow. So managing the air you breathe could potentially influence that whole chain reaction.
That's the idea suggested, that tackling environmental triggers, including airborne ones, could be part of addressing that larger susceptibility to allergies.
So it's definitely not just about, feeling comfortable. It could be tied to longer-term health.
It really underscores why the air inside matters so much, which naturally brings us to how air filtration systems, as described in these sources, are meant to help.
Right. How do they generally work? The sources seem pretty straightforward on this.
The basic idea is pretty simple, really. An air purifier or a filter in your HVAC system uses a fan. It pulls air from the room into the unit.
Okay.
Then that air goes through a filter, or maybe multiple filters, designed to trap all those tiny particles and contaminants we were just talking about.
Amen.
Then the cleaner air gets pushed back out into the room. It's just this continuous cleaning cycle.
Gotcha. And the sources mentioned quite a few filter types.
Yeah.
Mechanical, electrostatic, pleated, fiberglass, HEPA, carbon. Did they focus on one type in particular for allergens?
Yes, HEPA filters come up again and again. HEPA stands for high-efficiency particulate air.
Right.
And the key thing, the sources say, is they're designed to capture a really high percentage, 99.97% of airborne particles that are 0.3 micrometers in size.
99.97%. That sounds impressive, especially for things like pet dander, dust, pollens. The common allergy triggers the sources mentioned.
Exactly. That size range covers a lot of those common irritants.
Yeah.
And the sources also bring up the MRV rating system.
MRV.
Yeah, MERV. Minimum Efficiency Reporting Value. It's basically a scale that tells you how good a filter is at catching particles of different sizes. Higher MRV rating means it catches smaller particles better.
Okay, so higher is generally better for clean air. What range did the sources suggest for typical home allergens?
For common household allergens, the recommendation highlighted was usually filters with the MRV rating somewhere between 9 and 13.
MRV 9 to 13. Good to know.
Filters in that range are considered pretty effective for the particle sizes most allergens ride on.
Okay, so we get the threats, we get the basic mechanics of filtration. Now let's get into the nitty-gritty, because you shared this really interesting scientific study. This wasn't just theory, right? They tested this in actual homes.
Yes, this is where the sources give us some hard data. This study looked specifically at how well air filtration worked on actual allergens they tested for house dust mite, cat and dog allergens, and also just general particulate matter. And they did it in real bedrooms.
In Germany, wasn't it? Something like 22 bedrooms?
That's the one. 22 bedrooms in Bavaria, Germany. What they did was measure the air quality with and without a specific air purifier running. And they did it right after disturbing dust, like shaking out bedding, to simulate real life.
That makes sense. Very practical. And they used a Philips model, right?
Right.
With a HEPA filter.
Correct. A Philips air purifier AC4236. It has a HEPA filter and, importantly, a high clean air delivery rate, or CADR, of 500 cubic meters per hour. That just means it processes a lot of air quickly.
Okay, so what did they find, specifically about the allergens?
The results were, well, pretty striking. For the main house dust mite allergen, DIR-F1, using the air purifier led to a statistically significant drop. The median reduction was 75.2%.
Wow, a 75% median reduction in airborne dust mite stuff just from running the filter. That feels substantial.
It is, and the study showed it was highly significant, statistically speaking. They saw similar results for pet allergens, too. A median drop of 76.6% for cat allergen, FeLD1.
Okay.
And an even bigger drop for dog allergen, CanF1, a median reduction of 89.3%. Both of those were also statistically significant findings.
What about, you mentioned another dust mite allergen, DIR-P1?
Right, DIR-P1. It was reduced, too, by about 65.5% median, but that specific result wasn't statistically significant in this study.
Why not?
The researchers thought it might just be because levels of that particular allergen weren't very high to begin with in the homes they tested. But overall, the data really points towards filtration significantly cutting down airborne allergen levels.
And what about just the general dust and particles,
Yeah.
the PM stuff?
That's where the results were maybe even more dramatic. The study found statistically significant reductions in particle concentrations across every single size they measured.
Every size, from the tiniest ultrafine particles up to the bigger ones.
Every size. Ultrafine particles, PM1, PM2.5, PM10, all of them. The median reductions were huge, ranging from about 74% up to over 93%, depending on the particle size, and all highly statistically significant.
That's incredible.
And what's more, they noted that the air filtration didn't just reduce the levels, it did it fast. Compared to just letting dust settle naturally, the purifier dropped particle levels down close to zero in about 20 minutes after they stirred things up.
20 minutes, that's quick. So the study's main takeaway was?
Pretty clear conclusion based on their data. Air filtration works. It effectively removes airborne particles, and as a result, the allergens carried on those particles. They basically called it a fast, simple way to cut down on allergen exposure inside your home.
That scientific backing really does add weight to the idea of effective filtration. Now, building on that, one of the other sources you sent over introduces a specific type of technology.
Yes, this is where the sources talk about something called ActivePure technology.
ActivePure, okay. Where did this come from, according to the source?
The source mentions it has roots in a research partnership involving NASA and the University of Wisconsin, starting back in the 1990s, and it's been developed further since then.
NASA research. Okay, sounds pretty advanced. How does the source say it's different from the passive filters, like HEPA, that we just talked about?
The main difference highlighted is that ActivePure is described as, well, proactive. So instead of just passively waiting for air to get sucked through a filter, this technology is said to actively go out into the indoor space, air and surfaces, and neutralize contaminants, working 24/7/365.
Whoa, air and surfaces, and it goes out. That's definitely different.
It's a key distinction they make. It proactively deals with contaminants throughout the environment, not just what passes through the unit.
Okay. The source mentions it uses advanced photohydrolysis. Doesn't dive super deep into the how, but it does list what's supposedly effective against.
It does. It highlights proven effectiveness against dozens of contaminants, citing hundreds of lab and real-world studies. And it specifically lists things like MRSA, the virus that causes COVID-19, RSV, even monkeypox.
So tackling biologicals too, not just particles. And how does this ActivePure connect to the heart cells sources you sent?
there's a direct link made in the sources. One says something like, Heartsize has this space-age technology in every truck, tying it to their philosophy about air quality.
Okay.
And another source specifically promotes their whole home air purifier, stating it uses this advanced ActivePure system.
Right. So Hartzell's is offering a system with this specific tech. And the sources mentioned a particular offer, didn't they?
They did. They mentioned this whole home air purifier featuring the technology is offered at $499.
Okay.
And the source promoting it says it enhances air quality by helping eliminate odors, allergens, and pollutants. It even uses the tagline, "Clean air, happy home."
Sounds like it targets the exact issues we've been discussing, allergens like in the study, other pollutants mentioned with ActivePure. Now, there was a condition on that price, right? The source was very specific.
Yes, absolutely crucial detail from the source material. That $499 price is only valid with the purchase of any qualifying HVAC service.
Ah, so it's like an add-on when you're getting other HVAC work done.
Exactly. That's how it's presented in the source.
Got it. And for anyone listening in the area, the source includes a call to action. Contact us today, and specifically mentions the context is Oklahoma City.
Right. So that's the actionable info from your sources for folks in that area who might be interested in looking into this specific tech and offer.
Okay. So beyond getting a system installed, whether it's that one or another type, the sources also talked about keeping the air clean ongoing. It's not just set it, forget it, is it?
No, definitely not. Maintenance is key. The sources really hammer home the importance of keeping up with filter changes or cleaning.
Why is that so critical?
Well, think about it. The filter's job is to trap gunk. Eventually, it gets full, clogged up.
Right.
When that happens, it stops trapping effectively. Worse, it can actually restrict the airflow your system needs and potentially even start releasing some of the trapped stuff back into your air.
Yikes. Totally defeats the purpose. So what kind of schedule do the sources recommend for maintenance?
It varies a bit by filter type, as you'd expect. Things like basic pleated filters often need changing fairly frequently. Electrostatic ones might need monthly cleaning. HEPA filters, the sources say, can last longer, maybe up to a year, but still need regular checks.
And for the main HEPA filter?
The sources specifically recommend replacing those every 60 to 90 days, and they also suggest getting your whole HVAC system checked out by a pro periodically.
Makes sense. Were there other sort of simple tips and sources for improving indoor air generally?
Yeah, several good ones. Keeping your home's humidity below 50% is important. Helps control mold and dust mites. Using a vacuum cleaner that has a HEPA filter, so you're trapping dust, not just stirring it up. Definitely avoiding smoking indoors. That's a huge one.
Absolutely.
Taking shoes and coats off at the door can help stop tracking in outdoor pollutants and allergens. If you have pets, washing them and their bedding regularly cuts down on dander.
Good point.
And scrubbing areas where mold likes to grow, like bathrooms or damp basements. Just basic good housekeeping, really.
Those all sound like practical things people can actually do.
For sure. And the idea is that combining these good habits with an effective filtration system like the types discussed, including that specific technology mentioned in your sources, can really add up to a healthier indoor environment.
So let's circle back then. We started with that idea of invisible threats in your home's air. We've taken this deep dive into the sources you shared. Look at what those threats actually are.
Dust, dander, PM, viruses, bacteria.
Right. We explored how standard air filtration works, especially HEPA filters. And importantly, we looked at that study, solid scientific evidence showing filtration really can significantly reduce airborne allergens and particles.
And we also touched on that specific ActivePure technology and the related whole home air purifier offer from Hartzell's, as detailed in your sources, presented as a proactive approach.
So connecting this all back to you, the listener.
Yeah.
This information from your sources, it matters for your home. It could genuinely help you, as that hook suggested, breathe easier, maybe live a bit healthier, and just create a more comfortable space for you and your family.
Absolutely. And given that these threats are mostly invisible, and we now have this evidence from the sources about the impact filtration and simple habits can have, it really leaves a final question for you to think about. Based on all this, what steps might you want to take next to make sure the air you breathe most often, right there in your own home, is as clean and healthy as possible?